Hi, good morning, everyone. Once again. Hello, am I audible?
Yes, sir.
Okay, so yeah. So, yes, means Thursday live session we have covered up to attribute closure. So, everyone know attribute closure, or shall I repeat? Hello, am I audible, right? Hello. Yeah, everyone. Yesterday live session we have covered attribute closure. So, attribute closure, everyone know how to find the attribute closure.
No, sir.
Okay, so let me uh, discuss once again how to find attribute closure. Okay. My screen is visible. Hello.
Yes, sir.
Okay. So suppose there are relation R and the attributes are A, B, C, G, A, B, C, G, H, and the I. And the functional dependency given A determine B, A determine C, C, G determine H, C, G determine I, and B determine H. So if you want to find the A closure, AG closure, right? How to find? So AG will be covered AG, right? Now we can say the A determine B and A determine C. We can write A, B, C, then G. Then here you can see that CG determine H, right? We can say H. Then CG determine I. We can write I. So A, B, C, G, H, I. This is the how to finding the attribute clause. Suppose if you want to find the A closure, right? A closure, we can say that A determine B and A determine C. We can say A, B, C. Then C is that B determine H, right? A, B, C, H. So this is the A closure. So attribute closure is clear for everyone because we will cover extraneous attribute, canonical cover, and the equivalent set of functional dependency and the lossless zone and dependency preserving. So attribute closure is required. That's why I am asking. So attribute closure is clear for everyone.
Yes, sir.
Okay. Now we'll see the extraneous attribute. So what is extraneous attribute, right? So an attribute of a functional dependency is said to be extraneous if we can remove it without changing the closure of the set functional dependency. This is called extraneous attribute. So how to check extraneous attribute? So there can be possible right hand side and the left hand side. Consider a set of functional dependency and the functional dependency given alpha determine beta in functional dependency f. To test if attribute A belongs to alpha is extraneous in alpha. So if first this is the LHS. So how to test LHS, but if there is a LHS in LHS extraneous attribute or not. So compute alpha minus A closure using the dependency in F. Check alpha minus A closure contain beta. If it is does A, and it is it extraneous attribute. So let's see with the help of example, then it will be clear for you. Okay. Okay, suppose there are relation R contain ABC and the functional dependency A determine B and AB determine C. Now we have to check this A is extraneous or not. This A is extraneous or not. So how to check this A is extraneous or not? So AB, this is alpha determine beta, right? So alpha is AB. So this check A is extraneous or not. So AB, then we have to find alpha minus A closure, right? So AB minus A closure. So AB minus A will be B. So you have to find the B closure. So what will be the B closure? Anyone from this functional dependency?
Uh, Nothing.
Nothing. So
Nothing.
A is not an extraneous attribute. So now we have to check B is extraneous or not. So what we have to check? So B is extraneous or not. So AB minus B. So B minus B, what will get? A. So compute A closure, what will get?
AB
AB, right?
and
And from
C also.
yeah, on C also. So C. So we can say that this B is extraneous attribute in A, B determined C, right? So we will get C, right? We get C. We get C because we get beta. So this B is extraneous attribute in A, B determined C. So everyone got how to check extraneous attribute in left hand side?
So the extraneous is always on the left hand side?
Yeah, it can be right hand side. So I will be discuss right hand side also.
Okay, sir.
Okay. So left hand side is clear how to check the uh, uh, is that extraneous attribute present in the left hand side or not.
Sir, left hand side means what, sir?
Left hand side means alpha determine beta. This is LHS and this is RHS.
Okay, okay, sir.
Okay. So this up to this is clear.
Yes, sir.
Sir, in this case, this A plus, it will say A implies B, right? And
A plus, see, A plus, what will get? AB. Then from AB we get C, right?
why would we get A plus as AB?
Because from A determine B, right?
Oh, yeah. Okay, yeah. Got it.
Okay, so everyone clear with how to find extraneous attribute in the left hand side? Okay. Now we'll see the right hand side, how to test the extraneous attribute present in the right hand side or not. So how to check the extraneous attribute right hand side or not? Okay, first, uh, sorry, so you have to find the f dash. What is f dash? F minus alpha determine beta, then union alpha minus beta minus alpha. So we'll see with the help of example, this will be clear. So suppose there are relation ABC and the functional dependency given A determine C and the AB determine CD, right? So we have to find the in the right hand side D is extraneous attribute or not, right? So how to find? So we have to find the first F dash, right? F dash, what will be F? What is the F? A determine C and AB determine CD. So first we have to find um we have to subtract the alpha determine beta. So first we have to subtract alpha determine beta. So what will get? A determine C. Then union alpha determine alpha AB determine beta minus alpha. So we have checked D is extraneous or not. So beta minus alpha will be CD minus D. What will get? C. So AB determine C. So up to this is clear how to find the
Could
abdes.
you please repeat this? Not very clear.
Okay. So to test if attribute A is belongs to beta and is extraneous in beta. So let let us check. This is the relation R, and the relation consists of A, B, C, and the functional dependency given A determines C, and the AB determine C D, right? So now we'll check D is extraneous or not. This D. So how to first we have to find the F dash. So F dash what will get? F minus alpha determine beta. So this is alpha determine beta. So F minus alpha determine beta, what will get? A determine C. So A determine C. This is up to clear. This is
Yes, sir.
Yes,
now we
sir.
have to find the alpha determine beta minus alpha. So alpha, what is alpha? Alpha this AB determine what is beta? Beta is CD, right? Beta is CD, and A is we have to check D is extraneous or not. So CD minus D. So AB
Determines.
C. So Sunita, clear, right?
Yeah, yes, sir. Now it is clear.
Okay. Now we have to check alpha plus. So we have to check the AB plus with the help of F dash functional dependency. What will get AB plus? Anyone?
A, B, C, D.
A B C D. Yeah.
No, with the help of this functional dependency,
Oh, C then.
ABC.
Yeah, A B
So
C. Yeah.
we get D or not?
No.
So we can say that D is not an extraneous attribute. Now we have to check is an extraneous attribute or not. So if what will get the F dash? F dash will get AB determine D, right? This is clear. Now we check C is extraneous attribute or not. C. So F minus alpha determine beta, A determine C. Then AB determine CD minus C. So what will get? AB uh, determine D. So AB determine D. Up to that is clear. F dash.
Yes, sir.
So now we have to check AB plus with the help of this functional dependency. What will get? A determine C. AB determine C. So we get CD, right? Hello.
So it will be A, B, C, D, right?
Yeah, ABCD you can write. So AB is determine AB is travel. That's why I did not write.
Okay, sir.
You can write also
Yeah,
AB. So we get beta part, right? We get beta part. Whatever we get CD,
yes, sir.
then we can say that C is an extraneous attribute in AB determine CD. So extraneous attribute is clear for everyone. Or shall I repeat once again? Left hand side or right hand side?
Clear, sir.
So everyone is clear. Left hand side also and right hand side also. Everyone, hello.
So I think, what is the logic of I mean, checking that F minus and
So
how do we how do we logically remember this?
yeah, so let me so logically this is simple, right? So I will see. Okay. So left hand side is clear, right?
Yes, sir. Yeah.
Okay. So suppose there is A determined C and AB determined CD, right? So C is an extraneous attribute or not, right? So you have to find with so if you no if you break the dependency AB determined C, okay. So you have to find the AB closure with the help of this C A B C determine C D means with the help of if you break A B determine C and A B determine D, right?
Yeah.
So without the help of this functional dependency, we have to find the A B closure. So if you get A determine C, C will get, and A B determine D will get C D. So you can find that C D, right? So we can say that C is extraneous attribute. And if you find the AB D is extraneous attribute or not, so with the AB closure, so without the help of this functional dependency, we can say that C only C do not get. That's why we can say the D is an extraneous. C is an extraneous attribute. So this is the formal definition, and you can remember with the help of this.
Yeah. So in that, f dash equal to f minus alpha determines beta, that is trivial because you want to see if beta is extraneous or not, right?
Yeah.
Then there is a union, and then after that, that right hand side, what is the rationale for
Okay.
checking alpha determines beta minus a?
Okay. See. Okay. I'll give. Let me understand one second. Determine C and AB determine CD. So what will be the F dash? If suppose if you want to find the you know suppose if you want to find the D is extraneous or not. So F dash will be A determine C, and you have to remove the this AB determine D. This will AB determine D. No, sorry. First you have to find the C is extraneous or not. So A determine C, and you have to F dash will be don't write C here. So AB determine D.
Correct.
So then you have to find the AB closure with the help of this functional dependency. If you get beta part, what about the beta part CD? We can say the AB closure we will get CD. Then we can say that C is extraneous attribute. So
Yeah.
how to find F dash? This is clear, right?
Yes, sir.
Then suppose if you want to find the D is extraneous attribute or not, D is extraneous attribute or not. So what we have to do? First we have to find the whatever the functional dependency given A determines CD, A determines C. Then you have to remove the D
D.
part.
Yeah.
So you will get F dash will be A
AB
determine
determines
AB determines C.
C.
Now we have to find the AB closure with the help of this functional dependency. So what will get? Only ABC. We did not
Yeah.
get do not get D, but
D.
so that's why D is not extraneous
Extra.
attribute.
Yeah. Got it. Got it.
So clear. This is
Yeah.
simple.
Yeah.
I
Yeah.
think.
Yeah.
Okay.
So basically, the whole idea is it tells us if something is redundant, right?
Yeah,
Because
yeah, yeah.
by
Means
dropping
extraneous.
that, we don't really lose anything. We can recover. That's the whole concept
Yeah,
here.
yeah.
Okay. Okay.
So this when we will find the canonical cover, so this will be with extraneous attributes and the redundant functional dependency.
This formula we'll have to remember, right, sir? For exams and all.
Yeah, but you can. This is simple thing. I think RHS part is simple thing. Is left hand side part. This is simple. The
Yeah, that
confuse.
is simple, sir. The
Uh,
other one, the RHS, is a little tricky.
okay, this is also simple thing. Suppose how to find F dash. You have to find the F dash, right? So suppose if you want to find the C is extraneous attribute or not. So what we have to write? A determine C. What about the then you have to omit C, right? So you have to write AB determine D. Then you have to find the AB closure. If you will get C, you can say the AB closure will be ABCD. So we get beta part, right? CD. Then we can say that C is an extraneous attribute. Suppose if you want to find D is an extraneous attribute or not. So what we have to write? First you have to write A determine C. Then you have to write AB determine C. Omit D part. What about we want to find the D extraneous attribute or not? Do not write in the F dash. Then you have to find the AB closure. So what will get ABC? But in the beta part, you did not find the D, right? So we cannot say that D is not an extraneous word. So D is not an extraneous attribute. So F dash is simple, I think. Sunita, did you understand?
Yes, sir, I understood that. Yeah.
Okay, okay. So uh, I think uh, it is clear for extraneous attributes. So now we'll see the equivalence set of functional dependency. So when we can say that two equivalent set are functional equivalent or not. So like Fn and G are two functional dependency set. So when we can say that two functional dependency are equivalent when F closure equal to G closure. So don't worry, you will see with the help of example. So Fn and G are equal only if F cover G and the G cover F. Then we can say that F and G are equivalent. So we will see with the help of one example. Okay. Suppose X is A determined BC, B determined A, and the C determined A, and the Y is A determined B, B determined C, and the C determined A. Right. So first we have to find the X cover Y or not. How to find X cover Y? So okay.
So anytime we see a cycle, like here, let's say in Y,
Yeah.
right? I mean, we are seeing a cycle like A determines B, B determines C, and C it comes back to A, right? So um, usually you know that there is redundancy, right? You're not
Yeah.
supposed to have cycles.
So see, we'll see the equivalent set of functional dependency. So two sets of functional dependency are equivalent or not. That's why that's
Right,
an
right. Okay, got it.
okay. So how to find the X cover Y or not? So you have to find the closure set of Y, closure set of Y with the help of X functional dependency using and calculate using X functional dependency using XFD. So closure set of Y is A, right? What will be the A closure from this functional dependency? You have to find what will be the A closure. Anyone?
ABC.
Yeah, A B C. So B is coming, right? B is coming. Now you have to find the B closure with the help of this functional dependency. So what will get?
ABC.
Anyone?
ABC.
B A from yeah ABC. You can say C is coming. Then you have to find the C closure with the help of this functional dependency.
This is also ABC.
Yeah, ABC. So C is A is coming. So we can say that X cover Y is true. So up to this is clear how to find X cover Y.
So that is because Y also having A, B, and C, only those three elements, right?
Yeah. So,
Had it
so
been a
now
additional
see,
element, then it would have been the case, right?
X cover Y means you have to find the closure set of Y. X cover Y
Right.
closure set of Y. You have to find the A closure, B closure, and the C closure using the this functional dependency, X functional dependency. If it is coming, suppose if you find the A closure and B is coming, so this functional dependency is coming. Now you have to find the B closure with the help of this. So B determined C is coming, right? B determined C is coming, right? Yeah. And the C
Right.
closure, so A will also coming. So you can say that X cover Y is true.
So suppose Y also is having AB to C. AB determines C. Then what will happen?
Okay, so suppose what we want to find,
AB determines C.
AB determines C.
Determines C.
So you have to find the AB closure with the help of this functional
Okay, okay,
dependency.
okay, okay.
So A is BC. Yeah, you can say.
ABC to be
So
available.
yeah, X cover Y is true.
Okay, okay, got it. Thanks.
So everyone clear is how to find the X cover Y or not?
Sir, what's this AB closer using that X1
Which?
in the previous one that you took, sir?
Okay,
AB determined.
previous one. AB determines C. So
Yes,
you
sir.
have to find the AB closure
Yeah.
with the help of this functional dependency. So AB closure, what will get? A determine BC. So ABC will get. So you can say that C will get, right. So we can say that this is the you can X cover Y. Up to this is clear. How to find the X cover Y?
Yeah.
Yes, sir.
Okay. Now we'll see the Y cover X or not. Okay. Now you see that Y cover X. So how to find the Y cover X?
So now we have to use Y
Yeah,
functional definition.
yeah. Closure set of closure set of X using Y functional dependency. Y FD, right. So what will get closure set of A closure? We have to find the A closure, right? A closure using this functional dependency. We can say that ABC, right?
Yeah. Yeah.
So we can say that A determined BC is solved. So this is get. Now you have to find the B closure with the help of this functional dependency. So B determines C, C determines A. So you can ABC here you also got, and C closure can say C determine A. So directly we can C determine A. So we can say that this is also true. If both are true, X cover Y and the Y cover X, then we can say these two are the equivalent set of FD.
For equivalence set, we have to find X cover Y and Y cover X.
Yeah, you have to find the X cover Y
And both
and the Y cover
both
X.
should be true.
Yeah. So yeah.
So if we apply the transitive property to the first two in Y, A determines B and B determines C,
Yeah.
we would get A determines BC, which is equivalent to the first one in the X, right? So that's
Yeah.
kind of clear,
Yeah.
right?
Yeah. Yeah. Yeah.
Then the B determines A, we're trying to find out how it actually, if you combine B determines C and C determines A, you also get that.
Yeah.
So
Yeah.
essentially, because of these, using those two axioms, we can clearly see that,
Yeah. But
and
there
then
is
see,
if suppose
right,
there is big FD, so how to find this? This is the process of finding the.
right. No, I got it. But
Yeah.
this is the reason why, because if we started with Y, we could actually, create X by using the axioms.
Yeah. Yeah.
Yeah.
This
So
is
that,
actually simple,
yeah.
simple FD. So this is clear. Okay. So there is also one also practice assignment question, I think. So let's see. We'll see with the help of one question. We have discussed this. So what will this answer? I think this what, right? Hello, am I audible?
Yes,
Yes,
sir.
sir.
So X is A determined BC B. So what will be the answers? Oh, X cover Y, right?
All of them.
Yeah, it will be the all of the above. Okay. So then the questions. Okay, this. Okay, you have to find the, let's see this question. Yeah, so my screen is visible.
Yes, sir.
Okay, so you have to find the set of FDs equivalent. So there are, this is the, suppose this is the X, and you have to find the FDs equivalent. Which of the following is equivalent, right? So let me so this is X equal to, right, A determine BC, B determine C, and the C determine ED. So we have to find the which of the following is equivalent. Okay, let's first try this, right? So y will be A determine B, B determine CD, and C determine ED, right? So you have to find the, first you have to find the X cover Y or not. So how to find the X cover Y or not? So compute the A closure with the help of X functional dependency. So compute A closure. What will get? B BC, and from C. So we'll
Is
get BE,
the
right?
DE.
A B C E. We get B, right? So now we have to find the,
Sir, what about
So
D, sir?
even D, no? Even D,
yeah,
C is
yeah,
determining.
yeah, yeah. It also gets D, but we have to find the this B is no right hand side or not.
Okay, right,
See,
right, right. Okay.
so that's why I did not write. You can also write one.
Okay.
Okay,
And
now you have to find the bleak closure with the help of this functional dependency. So C and ED, right?
yeah.
B C E D. So we get CD, right? We get CD. So this is also. Now we have to find the C closure. C closure with the help of this functional dependency. C closure, so C ED.
D.
So directly ED. So X cover Y is true, right? Now we have to see the Y cover X or not. How to find the Y cover X or not? So you have to find the X closure set of X with the help of Y functional dependency. So you have to find the A closure. A closure Y will get BE from CD. B E C, we get BC, right? We get BC.
Yes.
BC. Now you have to find the B closure from BCE, and from C determine ED. C E D. So we get CD, right? We get CD, right? Then you have to find the C closure. So C determine ED, we can directly find. So this is also true. So this is the equivalent set of functional dependency. Now we'll see this example, second set. So this up to this is clear. Why first one is equivalent set of functional dependency.
Yes, sir.
Okay, now we'll see the second part. Okay, so X is A determine BC, B determine C, and C determine ED, and Y is A determine B, B determine D, and C determine E. So first we have to find X cover
Y.
Y or not. So first we have to find the Y closure set of Y using this functional dependency. A closure. Simply write A determined BC. So this is also true.
Yes, sir.
So this is also true. A determined. Then we have to find the B closure. B determined C.
Sir, how
And
did you get? We are using Y to cover X, right? Here, X cover Y means we are using.
see, X cover Y means you have to find the closure set of Y using the help of this functional dependency. So closure set of, we have to find the A closure also, B closure also, C closure
Using
with
X.
the using the help of this
Okay.
functional dependency. So if you find the A closure with the help of this functional dependency, you will get A B C. From
Yeah,
B
yeah,
C
yes, sir.
greater
So
than
B is there. Yeah, yes, sir.
E. So B is there. So that's why I did not write
Yeah, yeah.
other
Okay, sir.
things. Okay. Now you have to find the B closure. So you can say that B determines C and C determine ED. So D is there, right? Hello, Sunita.
Yeah, yes, sir.
Okay. With that,
Yes,
now
sir.
we have
Got
to
it,
find
sir.
the C closure with the help of this functional
E
dependency.
is
You
there.
can say
Yeah.
C determine ED. So E is there. Okay. So this is true. Now we have to find the Y cover X or not. How to find the compute X closure with the help of Y functional dependency. Now compute A closure. So I'll get A determined BD, A determined B. So we'll get AB, B determined D, we get D. We get only A, B, D, right? We do not get C.
Yes, sir.
Hello.
Not true. Yeah.
So this is false. So we can, this is not an equivalent set of FD. So how to find the equivalent set of functional dependency? It is clear, right, for everyone?
Yes.
Okay. So now I will see the canonical cover. Okay. Okay. What is canonical? Sorry. What is canonical cover? A canonical cover or irreducible set of functional dependency FD is a simplified set of FD that has similar closure as the original set of FD. So, we'll see with the help of example, right? So we can say that minimal set of FD, right? This is the minimal set of FD, and the suppose this property, and if it is canonical cover, right, then these properties should be satisfied, right? F closure should be equivalent to FC closure. So what will get canonical cover means both are equivalent set. Both will be the equivalent set of FD. Then second condition, no functional dependency contain an extraneous attribute. Next is each left side of functional dependency if FC is unique. That is, there are no two dependency alpha determine beta 1 and alpha 2 determine beta 1. So suppose we will see the alpha example. So A determine B and A determine C. We will write A determine BC. Right? Up to this is clear. Okay. And canonical cover of F is minimal set of FD and it is equivalent to F and having no redundant FD and no redundant part. And this is minimal and irreducible set of functional dependency. So we'll see with the help of example, we'll clearer how to find the canonical cover. Okay. F is A determine BC. So first we have to write the how to find the canonical cover. So process of finding the canonical cover. Okay. So first we have to find the how to calculate canonical cover. So first step is if there is A determined BC, you have to write A determined B and A determined C. Means all attributes on right hand side should be unique. And the second condition is find out if there are any extraneous attribute or not. If there exists extraneous attribute, then remove it. If exist, remove it. And the third condition is, then you have to, third step is find out if there redundant FD. If there are any redundant FD is there, then you have to remove it, right? So let's see with the help of an example. So suppose there are A determined BC, then A determined B, and B determined C, and AB determined C, right? So what I have to do? First you have to right hand side should be unique, right? So you have to break. So you have to write A determined B, A determined C, then A determined B, B determined C, then AB determined C. So up to first step is clear.
So
Hello? Okay. Now we have to find the extraneous attribute or not. So we have to find the, let's see, find the, no, B is extraneous or not. Hello. So how to find B is extraneous attribute or not? Anyone? Or A is extraneous. So let's find the A is extraneous or not.
the left hand side.
Yeah. So suppose you want, if we want to find the A is extraneous attribute or not. So how to find the A is extraneous attribute or not? Just to have covered how to find the
Alpha minus A we do, sir.
so AB. Hello.
Sir, AB minus
Yeah,
A.
Sunita.
If minus
AB minus A.
Yeah,
You have to find the closure, right?
B.
So what will be the AB minus A? B closure. So you have to find the B closure. So what will be the B closure?
C it would
C.
be
We can say
BC. Yeah.
so BC. We can get C, right?
Yes, right, exactly.
Hello. We can we get C. So B is extraneous. So if it is any extraneous attributes present, immediately remove, right? So what will get? A determined B, A determined C, A determined B, then B determined C, right? And again we get B determined C. Up to this is clear.
Yeah.
So you can see that A determined B and A determined B are duplicate. So you have to remove. And here also B determined C, B determined C. You have to remove one, right? So you can write A determined B, A determined C, and the B determined C. So up to this is clear.
Yes, sir.
Now you have to check the redundant functional dependency or not, right? So how to check the redundant functional dependency or not? Okay. So A determined B is redundant or not. So you have to find the A closure without the help of this functional dependency. You have to exclude this functional dependency. You have to find the A closure, right? Without the help of this functional dependency, what will get A closure?
C.
C.
So we do not get, right?
Yes.
So this is not a redundant functional dependency. So how everyone clear how to find the redundant functional dependency?
So you have to find the A closure using only those three, like a
Only two.
reduced elements in
Yeah.
the functional dependency. Okay.
Yeah. Now we'll check A determined C is redundant functional dependency or not. So you have to find the A closure without the help of this functional dependency. You have to exclude this functional dependency. So what will get? A closure.
BC.
BC,
We
yeah.
get BC. So we get C, right?
Yeah, it's redundant.
So this is a redundant functional dependency. Then you have to remove the redundant functional dependency. So A determine B and the B determine C, right? Okay, up to this is clear.
Yes, sir.
Yeah.
Okay, now you have to find the B determine C is redundant functional dependency or not. So you have to find the B closure without the help of this functional dependency. So I will get B closure, nothing
It's,
B. So this is not a redundant functional dependency. So canonical cover is A determine B and B determine C. Up to this is clear.
yes, sir.
Okay. So canonical cover is clear, everyone.
Yes, sir.
Okay. Okay. So I'll once again I repeat how to find the canonical cover. So first we have to uh, right hand side should be unique. So if there are like exist A determinant BC, so you have to write A determinant B and the A determinant C. Then you have to find the extraneous attribute present is not. So if there are present extraneous attribute, you have to remove immediately. You have to remove. Then
So,
after that,
yeah, so here in the second point, we're trying to find extraneous on the left hand side, right? Not on the right hand side.
yeah. So if you if there is exist A determinant BC, so you already write A determinant B and A determinant C. So right hand side should be unique, so right? So there is no.
Oh, yeah, yeah, yeah. That's right. That's right. Yeah, yeah. Correct. Yeah.
Okay, then
That's
you have to find the extraneous attribute. If it exists, remove it. Then you have to find the redundant FD. So if there are any redundant functional dependency, then you have to remove the redundant functional dependency. Okay, so everyone clear?
yes, sir.
Okay, so there is one practice 7 question, I think. So let's solve this practice 7 question also. I think this one is. Choose the correct canonical cover set of functional. Okay. Yeah, my screen is visible.
Yes.
Okay. So choose the correct canonical cover of the set of functional dependencies that occur are A, B, C, D, where F is given A determine BC, AB determine C, A determine D, and the D determine C. So how to find the suppose we have to F is A determine BC, AB determine C, A determine D, and the D determine C. Right, up to that is clear. Okay, so you have to right hand side should be unique, right? So you have to find the A determine B, A determine C, then AB determine C, then A determine D, and then D determine C. So this is clear, right?
Yeah.
Okay. Okay, now we have to first step. What is the first step? This is the first step. Second step is anyone?
We have
So
to
we have
find
to see the extraneous.
Yeah.
extraneous attribute.
So you have to find the extraneous attribute is not. So you can see that. Let us find the age extraneous attribute or not. So how to find the age extraneous attribute or not?
Find the closure of AB minus A.
So we
Yeah.
may say what will get B closure, right?
B closure.
So what will get B closure?
C.
Only
Oh, no, no, nothing, nothing. Okay.
nothing will get, right?
Yeah.
So we can say A is not an extraneous attribute. Now we have to find the B is extraneous attribute or not. So how to find the B closure?
A closure.
Sorry, A closure, how B is extraneous attribute or not. So what will get? Anyone?
B, C, D.
D.
Okay, A determine B, B, C, D. So C is appearing, right? C is appearing. So we can say that B is an extraneous attribute.
Extraneous.
So up to this is clear.
Yes, sir.
Yeah.
A determine B, then A determine C. Here also A determine C. So that's why I'm writing 1. Then A determine D, then D determine C. Up to this is clear.
Yeah.
Yeah, clear, right?
Yes, sir.
Yes, sir.
Okay. Now next step is, what is next step?
Remove redundancy.
We have to remove redundant FD, right?
Yes.
So how to find the redundant FD? So let us find the A determine B is redundant FD or not. How to find?
We'll find
Find a closure, sir.
without
A
using
closure
that.
with the
And
help.
see if B is there, or with the help of the other three, and see if B is there.
Okay. So we have to find the A closure.
No,
So
sir.
B is there.
No.
Yes.
No sir. So this is not an redundant FD, right? Okay.
Yeah.
Now we have to find the A determine C is redundant FD or not. So how to find? You have to find
Yes, sir.
the A closure.
C,
So
A closer.
D,
C.
C, B. You can see the C is
Yeah.
present.
So redundant.
So
Yes, sir.
C is redundant FD, right?
Yeah.
A determine B. You have to remove immediately. A determine D, and the D determine C, right? After this is clear.
Yeah.
Okay. Now we have to see that A determine D is redundant FD or not. So you have to find the A closure with the help of this functional dependency. What will get? Only get B,
B.
right? AB only get B. So this is not a redundant FD. Then you have to check D is redundant FD or not. So you have to find the D closure. So what
We
will
don't
get?
get. We don't get anything.
So this is the canonical cover. So you can say it. Sorry, this is the A determine B, A determine D, and D determine C. After this is canonical cover is clear for everyone, right?
So now it is clear. We have to just do those three conditions, and that's it,
Yeah,
right?
yeah.
So yeah.
Okay. So everyone is follow up, right? How to find the candidate key extraneous attribute. Hello.
Yeah.
Okay.
So this is slightly easier because extraneous attribute we are finding on the left hand side, so it's easier. I
Yeah,
think the
yeah,
one on the right hand side that was slightly
yeah.
more
So actually,
complex.
we first we have to already right hand side should be unique. So that's why.
Right, that helps us. Yeah.
So in the you have to find the redundant and functional dependency at the last. So okay. Up to this is clear for everyone. Extraneous attribute, how to find the equivalent set of functional dependency, and the canonical cover. These three things are clear.
Yes, sir.
Okay. And now we'll see the uh, decomposition is lossy or not. So, okay. So I think yesterday we covered how to find the decomposition is lossy or not. So this is lossless zone or lossy. So should I repeat or everyone got how to? Hello, am I audible?
Yes, sir.
So
So
please repeat once.
okay, yeah, we'll repeat 1 second. So okay, okay. So uh, you see that uh, due to redundancy, due to decomposition into several tables. So this decomposition is lossy or lossless zone. So this will be covered, right? So what do we mean by lossless zone? Lossless zone. Suppose there are relation R and we decompose into R1 and the R2, right? If we do natural join between R1 and R2, we will get original table. then we can say that this is the lossless zone. What is lossless zone? It is clear up to for everyone.
Yes, sir.
Okay. And if you do not get original table, if you do R1 natural one R2, and if you do not get if you do natural one R1 and R2 and do not get R, if we get extra attribute or we get less attribute or we do not get R, then we can say that this is the lossy decomposition. So up to this is clear. Lossless one and lossy decomposition. Lossless one
Yes,
decomposition.
sir.
Okay. Now we have to how to find the this is which one is lossless one decomposition and which one is lossy decomposition. We'll see. Okay. Suppose there is R and decomposition into R1 and the R2. So we have to find the three condition. If first condition, if we have to check R1 union R2 equal to R or not. First we have to check R1 union R2 equal to R or not. Then second condition is you have to find the R1 intersection R2 does not equal to 5. There exists some attribute. There should be, some attributes. There should there. Okay, so there should be some attribute, right? And the third condition is
So is it because if there is nothing common, you cannot take the union? Union
yeah
will be null set, right?
yeah
That's
natural.
the
So there will be some common attribute, right? Second condition means it is clear.
yes, sir.
Okay, and the third condition is this common attribute must be key in R1 or must be key in R2. Either this common attribute, what will be the common attribute, must be key in R1 or R2. So up to this is clear.
Yes, sir.
Okay. Now we'll see example with the help of example. Okay.
So
So
when we say key, it should be primary or
any key, any
any
key,
key.
yeah, it should be key means it should be identify all the attribute. That's
Okay, so even super key is
yeah,
also
yeah.
okay.
There will be a key. But okay. So we'll see on example. So the relation are A, B, and C, and the functional dependency given A determine B and the B determine C, right? And we have decomposed into two table R1 AB and the R2 BC. So you have to check this, these two are lossless one decomposition or not. So first condition R1 union R2 equal to R or not. So if you R1 union R2 will get A, B, C, right? So this condition is true. We get R. Hello.
Yes, sir. Yes, sir.
Okay. The second condition is R1 intersection R2 must not equal to null, right? So if you do AB intersection BC, there will be B. So this is not null, right?
Sure.
Okay. Then third condition
And B,
R1, yeah,
the B, this intersection should be a key in R1 or R2. How do we check?
yeah. I will check. I will. We'll see. We'll see. Don't worry. So next condition is R1 intersection R2 key in R1 or R1 intersection R2 key in R2 either. So first we have to check B is key in R1 or not. So what you have to do? Find B closure. Sorry. Find B.
So can't we directly say that R1 intersection R2 is B, so it is there in R1 as well as R2 in this case?
Yeah. So yeah, you can say that. So not there's intersection must not be not right. There
Yeah,
some common attribute will be present. So you can say that B is common attributes in both the cases, right?
yeah.
So you have to find the B closure with the. So this is key or
Okay.
not? We have to check, right? So B is key or not? So in a R1 table or R2 table. So we have to find the B closure with the help of this functional
BC.
dependency. What will get? Anyone? B, C, right? So we no,
We get R2.
yeah, in the R2 we can say that B is key in R2 table, because with the help of B we get C. So with the help of B we can got all the attributes. So B is key in R2 table. So this is a lossless joint decomposition. So someone asked how to find the key. So you got it?
Yes, sir. Yeah, that. So you have to use the functional dependency
Yeah, yeah,
and closure under the F given. Okay, got it.
yeah, yeah. This is so clear.
Sir, can you explain the third part once again, sir?
Okay. So you have to find the common attribute. Whatever the common attributes. So you can see the B is common attribute. You have to find the common attributes. You have to key in either table. So it should be key in R1 table or it should be key in R2 table. So you have to find the B closure with the help of this functional dependency. We can say the BC. We can say that B is key in R2 table, because with the help of B we find all the attributes. So B is key in R2 table. So this is a lossless joint decomposition.
So suppose the intersection gave us more attributes than one. So in
Yeah,
that case, we find the closure of all together, or we take the individual closures and
you
then
have to
do
closure of all together. Suppose
all
there is,
together, right, sir?
yeah, suppose I will see with the help of
Yeah,
example.
fine, sir.
Okay. Okay. So up to this is clear.
Yeah, yes, sir.
Okay.
Yes, sir.
Okay. Now
So
Sir,
there's
one
a
question. Sir,
question.
one question.
yeah,
So there's a question 5.5, question number 2. Can you please say this?
5.5 question number 2. Okay. Activity or
Yeah, activity
uh,
5.5.
5.5. Okay. So this
Yeah.
question, right?
So this third option
Okay.
is wrong in this.
Which option is wrong?
Third.
Okay. 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 I will see.
Okay.
We'll see. We'll see. So okay. Okay. So what is the question?
So I think this third option should be correct.
Okay. Yeah. We'll see. The relation are with the given function the A B C D with the given functional dependency B determined A determined E, and E determined BD into the three relation R1 AB, R2 C, and the R3 BED, and we have to find the correct option, right? So if there suppose there are more than decomposed into more than you know one relation, how to find the this is the lossless one or not? So first we have to find the R1 union R2 union R3 equal to R or not. So if you find the R1 union R2, what will get? A, B, E, then C also get, then D also get. So you find A, B, C, D, right? You find. So first condition is true, right?
Yeah. Yes.
Now second condition is you have to find the you have to see the common attributes, right? So you can see that there is a common attribute between R1 and the R2. You have to find the R1
E
common attribute. What is
E
the common attribute? R1 and R2. A. So you have to find the R1 2, and you have to check this two decomposition are lossy or not. You have to check this decomposition,
yes sir.
and you can say that E is the common attribute between R1 and R2. So you have to find the E closure, right? E closure. If you find the E closure from what will you get?
E B D
B,
A
B, D,
A
then B, D determine A determine E, right? So we can find A, B, and E. So E is the key in R1 table.
yes sir.
So R12 is lossless joint decomposition. So what will get? R12 will get A, B, sorry, A, B, C, and E. Up to this is clear.
Yes sir.
Now we have to check with the help with R3 table PD. So you have to find these two table lossless decomposition or not. So common attribute is
B
B, right? So you have to find the B closure. So what we will find? B closure. B
A
A
E
E
D
B D, right?
D
So B is the candidate key in R3 table. Sorry, B is key in R3 table.
yes sir.
So we can say this is a lossless joint decomposition. So that's why none of the above.
Okay.
So you got it. Everyone got it. How to find if there is more than decomposition to more than one table. How to find the this is lossless joint or not.
Yes, I got it.
Okay.
Sir, can you once again elaborate the steps, sir?
Okay. So yeah. Let me again the okay.
Sir,
Yeah.
sir, where will be the recorded session, sir?
Yeah, because in yesterday live session somehow did not live stream. I did not know some technical reason. So I and this session also did not live stream somehow so that's why I recorded the video and I'll upload into the YouTube. Somehow did not know I started streaming, but somehow some technical reason I think stopped the live streaming. So I'll recording this. That's why I recorded the session. So after the recorded, I will upload the YouTube. So don't worry.
Okay, so after uploading, you will upload in YouTube also.
Yeah, yeah, yeah.
Okay.
Okay. Okay. Okay. So there is a suppose let's take this example. R1 R equal to A B C D E and the functional dependency given FD given B determine A, then A determine E, then E determine BT, right? And decomposed into three table, right? R1 A B E, then R2 C, right? Then R3 B and D. So first step we have to find the union of the all the three, right? So first we have to find the union of all the three, R1 union R2 union R3. So you can get that, we'll get A, B, C, D.
R.
Yeah, we will get this is equal to R, right? Sorry. Now we have to find these two relation. We have to find these two relation are lossless joint decomposition or not. We can say that E is the common, right?
Yes, sir.
So we have to find the, let's name as temporal relation R12, and you have to find the E is the key in either R1 table or R2 table or not. So you have to find the E closure. What will get E closure? BD, BD from
A.
this,
Yeah.
uh,
Yes.
R from B determine A, right? And A determine E, right? So from B we get, B also, E also, and E also. So E is the key in R1 table, right? So we can say that this is the lossless zone decomposition, right? So R12, right? So this is the A, B, C, E, A, B, C. So R1 and R2, these two are lossless zone decomposition. Up to this is clear.
Yes, sir.
Now we have to check R12 and R3. These two are lossless decomposition or not. You can see that B is the common attribute, right?
Yeah.
So you have to find the B closure with the help of this functional dependency, right? So how to, if you will find the B closure, so what will you get?
A.
A, E, B, D. Yeah.
E, A, and D
D.
also. So
Yeah.
with the help of B you can find the D, right?
Yeah.
So this is the lossless joint decomposition. So we can say that this is the lossless joint decomposition.
So here we checked R, like R1 and R2, and then R1 and R3, right?
Yeah. So if there is, if some cases may become, I see this B is E is common in R1 and R2. If some cases may become, R2 and R3 may be some common attribute, then you have to check R2 and R3. Then R1, R first you have to check R2, R3. Then you have to check R1 and R2, R3. So you have to
So,
see
sir,
the common
if they,
attribute.
sir, if there are three attributes or more than two attributes, then we take a union of two and then check it with the
Yeah,
third one
yeah.
intersection.
You have to see the common attribute. Then you have to accordingly you have to check.
So, sir, similar to what R12 that you took, we should do for R13, R23, all those things, is
No,
it?
no, 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 no. See, sub. You have to check the, this, lossless decomposition or not. So first you have to check the R. You can see that R1 and R2 table is the common attribute.
Yes, sir.
So we have to find the R1 and the R2. So you can say that R1 and R2, this is the two lossless joint decomposition.
Yeah,
After this is clear.
yeah.
Then you have to find the R1 and 2 and R3. You can see that B is the common attribute, and these two attribute, R1 2 and R3 is lossless joint decomposition. Then we can say that this is the lossless joint decomposition.
Okay,
Up
okay.
to this is,
That should be enough, right,
yeah,
sir?
that should be enough.
Okay, okay.
Got it, got it. Because these two relations, if there is nothing common, cannot be joined
Yeah,
directly.
yeah, yeah.
Go through another relation which contains foreign keys and all that. Okay,
Uh,
makes sense. Yeah, yeah, yeah.
yeah. Okay. So Sunita and what is your
Yes,
name?
sir. Got it now.
Yeah. Okay. Okay. Now we'll see with another example, right? So then one tutorial also in lossless joint decomposition. You can also watch. I think Piyush had explained. Okay.
I think this session is helping, sir. I mean, there are a few doubts, but now I think it's getting
Yeah,
Okay.
this
clear.
is very good, sir, actually.
Oh,
It's step-by-step process, it shows you.
oh, okay. Okay. Now, thank you. Now there is it A, B, C, D, E, and G. And functional dependency given F equal to AB determine C, AC determine B, then AD determine E, B determine D, BC determine A, and AD determine G, and decomposed into 3 table, right? So R1 is A, B, C. R2 is A, C, D, F, and R3 is A, D, G, right? So you have to find this is the lossless joint decomposition or not. So you can see that first you have to find the R1 union R2 union R3 is R or not. So it is R. Anyone?
Yes, sir.
So we will get ABC, then AC, then D, F.
There's no E some. Oh, sorry.
E
There's
is missing, sir. E.
E is missing. I think E or F. I think it's a typo. Or,
But
yeah.
not.
Yeah, sorry,
Okay.
ACD.
Yeah.
Okay, sorry, ACD.
Now it.
Okay, so we'll get R, right?
Yes, sir.
So first condition is true. Now we can say that R1 and R2 table AC is common attribute, right? Hello.
Yes, sir.
Yeah.
AC.
So you have to find the AC
AC
closure.
closure.
Okay, what will get AC closure? From AC we can determine B, right?
BD.
And then
Yeah, so A, B, C. You can say that AC is closure, AC in key in R1 table because we find B. Hello.
yes, yes, sir.
So we can say that R1 and R2 is lossless zone decomposition. If you if it is key in either table, in R1 table or R2 table,
So if we
then
get it in R1, we stop. We no need to check in R2.
yeah, if it is there in R1 or R2,
Right.
all the attributes, then stop. We can say that this is key in R1 or R2 table. So we can say that this is a lossless zone decomposition.
Yes, sir.
So that R12 is what we'll get A, B, C, then D.
D.
Up to this is clear.
Sir.
Yes, sir.
Then you have to check R1 and R3 table. A, D, and G. Then you can say that AD is the common attribute.
Yeah.
You have to find the AD closure. What will get AD closure? Anyone?
EG.
A, D, E, G. Then you can say that the AD is the key in AD. This table R3 table because AD, G are coming. Hello.
So why not BC, sir?
BC means you can say that if you find the AD closure, we get AD and G also. So we can say that AD is a key in R3 table. We can say that. So if we natural joint between R1, 2 and R3, this will be the lossless joint decomposition.
So when there are multiple, sub-relation, whatever you want to call it, like R1, R2, R3, you start from the left, like R1, R2, then take the, once you prove that that's a lossless, then you take the combination, in this case,
No,
R1, 2.
sometimes you have to see the common attribute there. So if, suppose okay, let's take an example. So okay,
I think
suppose
if you take 4 and
yeah,
then
A,
R3 will
B,
not have anything with AB,
yeah,
then
yeah, R1 is suppose A, B, and R2 is suppose CD, okay, no, CD, and suppose R3 is uh, you know
it will not
BC,
work. I think you
right?
want to show that R1, R2 has nothing common with
Yeah.
R3.
So you
Then
have to
I think,
begin with
yeah, you have to start
R2,
with 4.
R2, R. So you have to see the common attributes. That's
Right,
the
right.
okay.
Yeah.
You can either start with R2, R3 or R1, R3, right?
Yeah, you can
Anything is
either,
okay.
yeah, you can either start.
So if we say, let's say R1 is AB, R2 is, let's say you're saying BC. We're just making it up, right?
Okay,
Just
let's
creating
R1 is,
Hypothetically, R1 is, let's say, AB,
yeah, R2 is,
R2 is BC,
okay, BC,
and then
then
R3 is DE,
DE,
and then R4 is, we have to do a link, BD.
okay, BD,
So
right?
our set, I mean the big R or whatever original R is ABCDE,
Ah,
right?
yeah, ABCD.
Yeah.
So you have to check the common attribute and you have to check common attribute is key in either table.
Yeah, and we haven't given the functional dependency,
Yeah,
but
you have given the
yeah,
functional dependency.
yeah.
Don't worry.
So here in this case, can I do R1, R2, then I do R3, R4, and then try to find out, is that
Yeah, yes.
possible?
Yeah,
See
we
that,
have to find the R1, R2.
yeah,
Then R1, R2, what will get? A, B, C.
right. Let's
Then,
assume it's a key, yeah.
yeah, then you can, B is common attribute in R4 table. So this is R1, R2. Then you can say that R1, R2, and 4. So what will get? A, B, C, D also. If there is, key attribute in, if common attribute is a key, then we can proceed with the R3.
Right, got it.
So you have to see the common attribute, what
Right,
happened.
right, right. So that's what we wanted to
Okay.
create a situation where it's not really sequential. You have to find.
So yeah.
No,
Okay.
what I meant to say, sir, I think Piyush sir has replied to that. It is like, can I take R1, 2, and then I take R3, 4, and then I try to find an intersection because there will be common attributes between R1, 2 and R3, 4 also.
Yeah, you can also
Is that,
take.
that is possible?
Yeah, so first we have to find what will R1,
R1, 2,
R1 2, what will get A, B, and C.
C, yeah.
And then,
R3, 4, so I get R, D, B, D, E.
oh, you can also take because,
Yeah, so B is a common attribute here.
yeah,
Yeah.
B is a common term.
Yeah.
Yeah, you can
So,
say,
yes,
So
Subandhu, I
one
just
of the
want to add
thing
one
is,
thing.
yeah.
so this functional dependency we get in these kind of cases, many times we see redundancy. Is it helpful to convert it to canonical form or just leave it as it is?
A little bit as it is.
Right, okay.
Okay, so lossless zone decomposition is clear. Hello.
Hello,
Yeah. Yes. Sir.
am I audible?
Yeah.
Yes.
There you are.
Subandhu, can you please go back to the slide, last slide?
Yeah.
Scroll down. Yeah. So here you had consider R1 to ABC, right? But for that, R1 2 should be a lossless decomposition, R1 and 2. Then only we can consider R1 2 as ABC.
Yeah, yes, sir.
Yeah. Directly we cannot take R1 2 as ABC. It should be a lossless decomposition, R1 and R2. Then we can consider that.
Yeah, so we
And
check for that
yeah.
lossless, and then if it is there, then we go ahead with.
Yeah. Yes, then we can do. And but one important thing is that when we are going for like next week, so we are using this decomposition concept in normalization thing. So there we are not decomposing one relation directly into R2, R3, R4 like that. First we decompose that relation R into R1 and R2 and see whether we are satisfying our condition or not. Then again we decompose R2 into R3 and R4. Then again we decompose R4 into R5, R6. Like that we go. Means at a time we decompose particular relation only in two sub relations only. Here we are just checking whether our overall decomposition is lossless or not. But when we are going for normalization, at a time only two relations will be there, like while decomposition.
Okay,
Yeah.
sir.
So that's why in the slide only R1 R that condition is mentioned, right? Decomposition, only two attributes. So that we'll discuss in next week. No issue.
Yeah, makes sense.
Okay. So up to this is everyone clear?
It's very helpful, sir.
Okay. Now we'll see the dependency preserving, right? Okay. Okay. So we have suppose there are relation R. So relation R, and the given functional dependency F corresponding to F, and we have decomposed into two tables, right? R1 and the R2. Now and the corresponding R1 table is the F, and a functional dependency given F1, and the corresponding functional dependency given F2, right? So we'll see the dependency preserving in subtable or not, in decomposition table or not. So in if suppose F1, so 1 minute. F1 union F2. There is and decomposition, right? So dot 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 Fn. This closure is equivalent to F closure, right? So we'll see with the help of example. Don't worry. Okay. So suppose there are. Okay, let's see one example. Okay, we'll see one
So
example.
basically, what you're trying to say, we have to take the elements of the FD sets to decompose in a subsequent down the chain, and then,
Yeah,
huh?
we'll see with the help of example, then you will understand, right? So suppose there are relation R ABC and the functional dependency A determine B and the B determine C, and we decomposed into two tables, right? Like this is the R1 table AB, and this is the R2 table BC, right? So we have to check no functional dependency are preserved or not. So what about the functional dependency given? This functional dependency preserved in child table or not? So how to check the functional dependency is preserved or not? So first we have to find the corresponding F1 functional dependency. So what I will get? So what about the given? So first we have to find the A closure with the help of parent functional dependency, right? Hello, hello, am I audible?
Yes.
So
Yes.
what will get A closure with the help of this parentable functional dependency?
A, B, C,
Okay, A,
B,
B, C.
C.
But we can say that in R table, A and B is present. So A determine B. We can write from that, right? A determine B. We have to take what are the attributes present in the R1 table. So the A and B is the present. So you have to take only no B. So A determine B is. So this is clear, right? Hello.
Yes.
Then you have to find the B B closure, right? So what will get B closure?
B, C.
B C. So from B we can determine, you can see that AB, so we can determine only B, so B is nothing, right? So our so B determine only B, right? Now we have to check the F2. So B closure we have already find B, so B determine C. Then you have to find the C
C
closure.
close.
So what will get? C closure is nothing, C only say C determine C. Then we can say that A determine B is preserved, right? A determine also is preserved, and B determine C is preserved. Here we can say that. So this is the dependency preserving.
Basically, sir, the union of these two
So
should give us the F. Okay.
yeah. So okay, now we'll see another example. So suppose there is it is decomposed into suppose AC table. AC table, right? So you have to find the whatever the you have to find the A closure. What will get?
A, B, C,
A closure. So we can determine A determined, sorry,
C.
A determined C, and we have to find the C closure. C closure is nothing, so C determined C, right? So you can see that A determined B is preserved, right? Hello.
Yes, sir.
But B determined C is not preserved. So what we have to do? You have to find B closure with the help of this parent child level functional dependency. You have to find the B closure with the help of this functional dependency. What will get?
B closer. B.
B and
Yes.
nothing, right? So B determines C is not preserved in the child table, so this is not a dependency preserving.
This is also lossy decomposition.
No, this is lossless zone. This see lossless zone decomposition and dependency preserving. These two are mutually exclusive. It may be lossless decomposition, but not dependency preserving. It may be dependency preserving, but not lossless zone decomposition. This is two different things, right? So if if you find the lossless or not, so you can see A B and the AC, right? So you can see that R1 and R2 A B C, right? And the common attributes should be key. You can see that if you find the A closure A B and C, so you can see that is key in R1 table. So this is the lossless zone decomposition. So these two are different things. So this is not a dependency preserving but lossless zone decomposition. So this is clear up to dependency preserving is clear.
Yes.
Okay. Now see
Sir,
with the
just out
another
of
example.
curiosity, sir, for any database management system, shouldn't both of them be necessary that it be lossless
Yeah,
as well
both.
as dependency
Uh,
preserving?
yeah, this to be necessary. That's why you go, in industry maximum is up to 3 NF. So BCNF will understand,
Yeah.
in
Yeah,
week
the
six.
3NF, 1NF is not very clear to me, sir. I mean, from the
Yeah.
lectures.
So I will see in the week 6 lecture. So we'll
Okay.
understand in
Okay,
detail.
sir.
Okay. So we'll see another example. Okay. So sorry. Uh, A, B, C, D is given, and the functional dependency given. A determine B, and the B determine C. C determine D, and the D determine B, and the decomposition into three table: R1 AB, R2 BC, and the R3 BT table. So you have to check the this child table decomposition dependency preserving or not. So how to find the first? You have to find the A. So find out the A closure from the parent table functional dependency. Remember, from the parent table functional dependency. What will you get? Anyone?
ABC.
BCD, BCD.
A, B, C, D. So
Yeah.
you can say that A and B only two attributes present. So we can say that A determine B. Up to this is clear.
Yes.
Okay. Then you have to find the B closure also. Sorry, from the B closure. So what will you get? B closure equal to
BCD.
B C D.
B, C, D. So now we do not get A, right?
Yes.
So it will nothing. So A determine B, right? Now we have to check the R2 table. So R2 table, what will get? B. So you have to find the B closure. So B closure we get B, C, D. So you can write B determine C, right? Up to this is clear.
Yes.
Now we have to find the C closure also. So C closure, what will get?
C D B.
C, D, B. So you can write C determine B. This is clear.
Yes.
Okay. Now we can check R3. You have to find the B closure. So what will get B closure? B, C, D. So you can determine B determine D, right? Hello.
Yes.
Now we have to check the D closure. What will get?
D B C.
D, B, C. You can write D determine B, right? Now we can see that A determine B is preserved. A determine A is preserved. B determine C also preserved. B determine C also preserved. D determine B also preserved. D determine B also preserved. Now we have to check C determine D is preserved or not in child table. Directly we can set A determinant B is preserved, B determinant C is preserved, D determinant B is preserved. But we have to check the C determinant D is preserved or not. So what we have to do next? We have to find C
C
closure
closure.
with the help of child table decomposition, child table functional dependency. With the help of this functional dependency. Remember, with the help of this function, what will get C closure?
CBD, sir.
CBD,
C from C determinant B. So C B,
BD,
and from B determinant D we can get D. So you can write C determinant. You will find D, right? So it's C determinant D is preserved. So this is a dependency preserving. So process of finding the dependency, how to check the dependency preserving or not. It is clear.
yes,
Sunita, clear?
Yes, sir. It's very much clear.
Okay.
Yes, sir.
Now suppose if there is no like this 2 3 attributes, so how to check the functional dependency is preserving or not. So we'll see. So first we have to find the A closure, right? A closure. What will get A closure? Anyone?
A closure will be
A.
A, sir.
A closure A, so nothing, and B closure will be nothing.
Yes.
Okay. So in corresponding R112 we do not get anything. Now we have to check. First we have to check C closure. So what will get C closure? Anyone?
D, E, F,
Yep. C, D, E, F.
Okay. So we can write. Okay. C closure will get D, E, and F, right? Up to this is clear. Hello.
Yes. Yes, sir.
yes, sir.
Okay. We can write C determined D, E. This is clear.
So should we directly write DE or should we write C determines D and C determines E?
Yeah, both are the same thing. C
Same only,
determined.
okay.
Yeah. So if you go in, both are the same thing.
Fine, sir.
Okay. And now we have to find the D closure. What will go D closure in? D closure. What
D,
will get?
E, F,
Hmm?
D,
D, E, F.
D, E, F. So from D we can determine E. Okay. Now we have to find the E closure.
E, F,
So if we find the E closure, what will get? E and F,
E,
right?
yes,
So E and F, nothing will get. So D closure is okay. Now you have to take the combination of two attribute CD. So you have to find the CD closure. Combination of C, D closure. So what will get CD?
D,
D,
E,
E, F, sir.
F,
D, E, F. So CD determined only CD determined only
DE.
only D. Okay. Then you have to take DE. CD D. D. What will get? D closure.
E,
PE itself, sir.
So CD is
D, E, F,
D. So only get E, right? D only get E. So this is triple functional dependency. Now we have to check CE, combination of all the two attribute. So what will get? C.
D, F,
Hmm?
D,
C, C D. Okay, so C D E. So only gets D, right? C, because CD is present. CD is an attribute. So up to this is clear. How to find the. So if there is more than two attributes present, first you have to take single attributes, then combination of two attributes, and there is four attribute is present, then combination of you have to take 3 attributes. Just you have to like this proceed. Hello. This is clear, right? How to this is
Yes, sir. How we are getting C closer as D, sir?
C closure. You have to find the
CE closer.
okay CE. So
Yeah.
what will get CE, and from C you get D, right?
Okay.
So we can write C closure D. So C with the E is extraneous, right? So because with the help of C we can D. So you can this just
Sir,
write.
sir, can't we find A closer in R1 by using AB?
Yeah, we have to find the yeah, you have to find the E. So see A closure. What will get
Uh,
with the help of parental functional dependency?
yes, B, C,
A with the help, only A closure. What will get?
only A closer.
Yeah, only A closure.
Sir, A is not present in this.
So it is A only determine A. And if you find only B closure, what will get? Only B, right?
Yeah, but why we are using in this one R2CE closer, but C is not present in this
C is present, right? C is present.
CE CE closer that we are finding, sir, here.
Yeah. So you have to take combination, right? See, first you have to find the if there are more than three attributes present. Suppose you can see the C, D, E present. So first you have to find the whatever the C, functional determinant. You have to find the D. Then
Yes,
you
sir,
have to
that
find
is clear, sir.
yeah,
But when we are taking two at a time,
yeah,
then we
yeah,
are going into the F to find out the
yeah.
dependency. But CE is not present in the F, sir.
C is
Go
present, right? C is present.
actively. Yeah,
Huh?
C is present, E is present. Yeah, that's clear.
Yeah.
But when we
No.
are taking two at a time, like
Yeah.
AB, sir, AB is present in AB is determining CD.
So yeah. Okay. Let's see. If you find the AB closure, what will you get?
CD, sir.
CD. But in the
C.
R1 table, only A and B are present.
Okay.
So we take whatever the attribute is present. So we cannot write AB determine CD, right? We cannot write because only A and B is present.
Yes, sir, that is clear, sir.
Yeah. Clear? Your doubt is clear?
No, sir.
So, Sridhar, are you asking about CE determine D, how it came, right?
Yes, I'm also asking that C is not present in the F dependency.
No, no, C is not present, but C is present. C is determining D, right? So
Yeah,
from
yes, sir.
C we can write D.
Yes, sir.
Yeah, yeah. From C we can write D, or from E are we getting anything? No. So you can take individual attribute also. It's not like that C should be there. If
Okay,
C
sir.
is there, from C we can determine D, so we can write D also.
Okay, but using that concept, sir, AB is there and in R1 A is there. So can't we take the individual A from F?
No, 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 no. In functional dependency, AB determines CD, so you have to consider AB only. But while
Okay.
computing the closure of CE, you can either take C or E or combination of CE.
Okay, sir. Now I got
Yeah,
it, sir.
yeah. So
Thank
in closure means C will also determine C and E itself, right?
Yeah.
By trivially. So from C I can get D. From E I am getting F. So closure of CE will be C E D F.
Okay,
Okay.
sir.
Yeah.
Thank you.
Okay. Yeah.
Okay. Now we have to find the E closure with the help of parent double functional dependency, right? So what will get anyone? E closure E equal to EF, right? So we can determine E determine F, right? Now you have to take the F closure, right? So what will get F closure? F closure will nothing get. So right. Now we have to check the dependency preserving or not. So you can see that C determine D is preserving. So you can see that C determine D is preserving. D determine E also preserving. D determine E also preserving. D determine E also preserving. And E determine F is also preserving. E determine F is also preserving. Now you have to check AB is AB determine CD is preserving or not. So you have to find the AB closure with the help of this child table functional dependency. What will get? AB, only get AB and nothing will get. So this dependency is not preserving. So you can say this is not a dependency preserving. So dependency preserving is clear for everyone.
Yes, sir.
Okay. Okay. So any doubt in week 5 you can ask. Hello.
I think we have plenty.
So if you have any doubt in week 5 activity question, practice question, you can ask. Or otherwise you can wind up the session. Okay. Thank you everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah, thanks.